Hey, Trevor Matthews here. I hope you're having a fantastic week. So, I've been deep diving on CO2 refrigeration for 6, 7 years now, just still learning it. I believe it's going to be the commercial refrigerant globally at some point. If you start learning it now, you're going to prepare yourself for the rules and regulations that are coming up in a lot of countries around the world. And you're going to see CO2 continue to grow in the CO2 space. I found this awesome diagram from Bitzer, this animation. I kind of want to go through with you just to kind of give you an idea of what a transcritical booster system is. And when you start working on CO2, just know that it's nothing to be afraid of. It is still a refrigerant. It runs at higher pressure. So there are some safety factors that you need to really understand. But I really think this is a great diagram and animation that you could show other people. And I highly recommend that you do that. I really learn a lot more by training others, by sharing my knowledge. And I'll walk through this with you. And then what I want you to do is walk through this with somebody else as well. And just get yourself more familiar with a CO2 system because you will be working on CO2 refrigeration if you're not already. So as you can see up here are medium temp compressors. This is the discharge line, okay? As it comes out of the discharge line here, you have a safety valve, and then you have oil separator. There's a little plus sign here. You can open up and see inside the separator what is going on. What the separator does, it separates the oil from the refrigerant. The pressure in this line, can be anywhere between 900 psi all the way up to 1,500 psi, right? Depending on the ambient temperature and, well, the way you want to run it, because maybe you're doing heat reclaim or something, so you are running it in transcritical mode. The separator separates the oil goes into the reservoir here that you can turn on and turn off if you want to look at it, this little button. And then this goes back and feeds the oil regulators. So, OM5, OM3, OMC, the Carwan modules, there's so many different ones out there. So to make sure you maintain oil level in there. And then you have another pressure relief here back into the suction. Okay. From here, you're going to the gas cooler condenser. It's called a gas cooler condenser because when it's above 87.8 or 31 degrees Celsius, it is not a condenser anymore. It's a gas cooler. You're only trying to reject heat. You're trying just to cool it down. That's why you call it a gas cooler. From here, you're going into a plate heat exchanger. And then you go into what we call our high pressure valve right here. So this, as you can see here, this is a Danfoss high pressure valve. And then you go into your flash tank receiver. And if you want to look inside, you can look inside. The other valve that works in combination with this high pressure valve here is this flash gas bypass valve. And so what this valve does, it maintains the receiver pressure, and this high pressure valve here maintains the gas cooler condenser pressure. So just think of it like that. This high pressure valve is controlling the gas cooler condenser. This flash gas bypass valve is controlling this flash tank receiver. So what it's doing is bypassing gas to make sure you have a good quality of liquid and good pressure liquid going to all your loads, all your cases, plate heat exchangers. So as you can see here, here's the liquid off the bottom of this receiver. It goes down into a filter dryer, and then now it starts to feed your different cases. So it will do both your medium and low temp cases, which is really cool, this liquid line. So we go into a plate heat exchanger here. There's a safety valve there. You really got to remember, you never want to trap CO2. CO2 expands so fast, unbelievably fast. So you got to have a lot of safety valves, check valves around different things. So now we feed this plate heat exchanger. We'll go down through the plate heat exchanger, and then now we'll feed into our electronic expansion valves, as you can see right here. So these EEVs, you cannot use TX valves with CO2 because they do not react fast enough. You use electronic valves, and then you feed into the case. If you want to change it to Fahrenheit, you can. Celsius. Oh, I started the animation. I want to do that a little bit after. So now we feed this case. So we're cooling this island refrigerated case, and then we go over, and then we go back through the plate heat exchanger, the suction line, back into the low temp compressor. Why that it's designed this way? And there's many different designs. You know, you got to check out the manufacturer's design in the rack. But what that is for, this plate heat exchanger, is really to increase the superheat. So you have like a 20K, 25K superheat, or a 36 degree or 40 degree superheat for these low temp compressors, because that CO2, the way it mixes with the oil, when you're below that for your low temp compressors, the oil is saturated and it's really soluble with that CO2. And what happens, it starts to flood back, even though you have, say you had 10 degrees superheat at that compressor, or 5 or 6K. That's not enough superheat, because at that point, that CO2 is going to be, the oil is going to be full of CO2, and it's going to start wearing the bearings. And that's one of the biggest failures that they're seeing with CO2 and the compressor manufacturers, is low superheat or flood back, even though because you need to maintain that 20K, 25K, or 36, 40 degree Fahrenheit. And then we go back to the low temp compressors. Then you can also see right here, as we go down here, we now feed, so that we feed another case, EEV. These are the medium temp evaporators. The other one were low temp, sorry. And then still EEVs, you got sight glasses there. And then now we go into a suction filter, and then back to the medium temp. So you'll see on the transcritical medium temp side, you'll be running, you know, say 1,000 on your discharge, 450, 500 on your suction. If I talk in bar, you'll be running at, say, 90, 100 bar. And then on your low side, you'll be running, say, 30 bar, 40 bar on your suction side, sorry. And then for your low temp, you'll be running around 450, 500 PSI, and probably 200, 220 PSI. That's around minus 20 Fahrenheit. And that's kind of the way it works. I'm going to shoot the animation on right now. So here's the animation. As you can see here, it's discharging out, gas cooler. You can see that you get the high pressure valve here, opening and closing, flash gas, high pressure valve, controlling that gas cooler. Like I said, you get this flash gas bypass valve controlling the receiver here. And then, as you can see, your liquid feeds both your medium temp and your low temp systems. What's cool about this, I didn't mention this, on the low temp side, you can see the discharges into the suction. So there's going to be many different designs. This could be discharged into the receiver, depending on the type of design. We'll go just into transcritical mode, and then you can go to subcritical. So you don't have all the medium temp compressors running. One thing you need to be aware of, you cannot run your low temp compressors without the medium temp. As you can see, the discharge of the low temp is pumping right into the medium temp. So if you try to start the low temp, or you shut the medium temp circuits off, the transcritical circuits, you're probably going to blow a charge. So just be aware of that. So I think this is a really cool diagram to take a look at it, just a basic transcritical booster system. I'd love to hear your thoughts. Shoot me an email, shoot me a message, and really use this document. I'm going to put the link to this animation in this email, as well as I would love for you to share it with other people, but when you share it, review it with them so you can talk just the way I did to you, so you get better at training the next generation of apprentices and journeymen and refrigeration professionals coming out there. My name is Trevor Matthews. Let's get a conversation going.